welcome to the next episode of Meet the Oracle Masters, building REST APIs for the Oracle database by Jeff Smith. Don't forget to join us for the remaining program. Next week, there's no session, but the week after, starting the week after that, we got another lineup for you guys and girls. And since you're actually you have to run right after this, I don't think I'll take up more time, so give it over to you, Jeff. Take
Thanks,
over
Patrick.
the screen.
Don't miss Jim's talk on the 9th. Jim's a great presenter. He's got a DBA focused mind, but he's very developer friendly. And the topic he's going to present on is kind of interesting. So if you're seen Mongo before, or if you've had experience with NoSQL, then there's a lot of things the Oracle database can do to enhance that and give you a true ACID compliant performant solution for JSON documents. So I'm guessing Jim's talk will be a lot of fun. So
too.
Enough of the commercial for Jim. Let's talk about our stuff. I'm a product manager at Oracle. You can contact me email if you want. If I don't reply right away, you're probably going to need to send me a reminder email later. And if you want to talk to me on Twitter, I try to be active on there. I guess I'm fairly active on Twitter, I guess you could say. And everything I'm going to talk about today, I've also got in-depth blog posts to cover all of this stuff. And what we're talking about today are REST APIs for the Oracle database. So just to self-promote, because I'm an attention pig. If you do come to my website, up top I have these resource links, and if you click on words, I tried to organize things that people are looking for, so it's a little bit easier to find.
Jeff, we're still seeing the slide.
No? Share screen. Are you seeing my browser now? Okay.
Yep.
Yeah. So on my website, I've got some resource pages up top, and if you click on words, I have popular posts and examples and how to get started links here. All right, can you see my slides again?
Yep.
Okay, good. So REST APIs for the database. How do we make that happen? Or why do we even care about REST APIs? Let's go back to why we care about REST APIs maybe. Hello, go back. Slide. Yep. This is new computer fun. Okay. REST APIs are basically the easiest and most ubiquitous way for communicating between programs or machines or entities or things in the world right now. For the Oracle database, we're used to setting up an Oracle client, getting a TNS names, and SQLnet configuration going. You create these stateful permanent connections to the database. You're doing commits and rollbacks. And that's a very well-known process. And if you're on a Mac, it's even more complicated for setting up an instant client and dealing with Mac security and libraries. But that's how you would use SQL+, that's how you would use SQL Developer, that's how you would use almost any desktop application built for Oracle in the last X decades. But ever since the internet kind of took off, HTTP, and more importantly, HTTPS, has become the predominant method for communication between things on networks. And REST APIs allow you to interact with things via HTTP. And with the love affair that developers have developed with JavaScript initially, and this JavaScript object notation or JSON. JSON and REST APIs have kind of become, well, I mean, JSON documents are also the predominant way people like to communicate information between each other. And REST APIs are the vehicle for trading that information. So you're using this for almost all kinds of things right now, like automation. You'll see implemented via curl scripts that are just calling APIs that go and do the work that you want to be done. That could be creating a new machine in a cloud somewhere. So it doesn't matter if it's Oracle's cloud or Amazon's cloud or Microsoft's cloud or Google's cloud. If you pull up their docs, everything they've ever built will have corresponding REST APIs for those. You could be building a mobile web application. You could be building a desktop application. You could be building just websites. By far, the most common way for implementing all of that's going to be HTTPS right now. And the reason that's one is because it's easy. There's nothing to config on the client side except for maybe a security token or maybe an SSL cert. But there's no Oracle client to install. You just have a resource described by a URL or a URI, and you're making calls on that thing, assuming you have an account that gives you the ability to do that. So we don't want the Oracle database in this closet somewhere where it's not able to play nicely with everything else in your IT infrastructure. So we want to be able to have REST APIs for the database itself and for the things inside your database. And then once you have that, when you talk to someone that has like a forms application built in the 90s or early 2000s and they want to modernize that, one of the easiest ways to do that is take the existing PL SQL that they have defined in the database where all the business logic is and just put REST APIs over top of that. So once you have REST APIs over top your stored procedures, it's very easy to build web pages and applications that go and do all of the work that your forms apps were doing. What I want to talk about today is how you can use Oracle REST data services, which is what the database gives you, to make REST APIs available for your database happen. So I'm just going to call it ORDS. We're very much acronym focused at Oracle. I hate that, but Oracle REST data services, it's free. It's a no-cost feature of the database itself. It's not part of the database in the sense that you install the database and it's there. It's a separate download. And you would normally install it on where your mid-tier goes, like with the rest of your web servers. So if you've got Tomcat or Apache running somewhere, you would generally put ORDS in that same sort of zone. You wouldn't necessarily have it on the same machine as the database. And that's adding this bridge or this sort of gateway per se. You're going from HTTP and you want to talk SQL. And on the other end of that gateway is an Oracle database. So you're making HTTP calls. ORDS is saying, hey, Patrick wants to do a post on our AWR module, and he's asking to create a new snapshot. So ORDS knows tied to that post request inside the database, there's going to be a PL SQL call that exercises the AWR PL SQL API. It's going to go run that. It's going to get its result set back, which is probably either going to be a ref cursor. In this case, I think it's just a standard out message. And it's going to create this thing, this snapshot. What ORDS is going to do is say, hey, let's express that response in a way that makes sense when you're dealing with HTTP. So we need to return a status code at 201, which tells the caller, hey, that thing that you just did, it worked. And not only that, it created a new thing. And oh, by the way, here's a link to that thing you just created. In this case, I'm going to give Patrick a link to the snapshot that was created. And with that link, he can click on that to go see the thing that he built. So REST is stateless. And so since you're in a stateless environment, every call that you make needs to include all the information required to do the work that's to be done, because the database or the ORDS has no idea that you belong to session ABC and that you have all these things predefined. So all of the work that comes in has to be atomic. And so you have to give your application or your users a path to walk, and that's accomplished by links. So literally, web links. So your app knows what the next thing to do is, and there might be a series of links that you could follow. ORDS makes this database work, whether it's SQL or PL SQL based, available to your HTTP based APIs. So if Patrick instead wanted to do a GET on a snapshots resource, and in my database, I've got 10,000 of those, he probably doesn't want to get a JSON payload of 10,000 records onto his mobile app. He probably just wants to see like the last 10 that were created. And in his app, he'll have like some interface that allows the user to filter or page through them. So one of the things ORDS does is when it detects in a SQL statement that's tied to your API more than, say, 25 records being returned, it breaks those results up into those pages. So each call, you're asking for a specific window of records, and it's doing all of this work for you. So the rest can be as complicated, as powerful, as beautiful as you can manage with your SQL and PL SQL. And you can literally do anything in the database via these APIs, because you can literally do anything with SQL and PL SQL. So you could create a new pluggable database, you could truncate a table, you could create a user, we could drop Patrick's user, that would be mean. You're basically limitless in what you can do with these APIs. So when you deploy ORDS to your mid-tier, you're going to set it up for one database, and then a second and a third or a fourth, and however many you need to plug in. So you could put it to a container database, and then that container database, you could have 300 pluggable databases where they would all be serviceable. You can point it to an individual PDB. You could have a dozen 11.204, 12.1s, and 12.2 instances that are single architecture, not multi-tenants. And you could have all of those configured with a single ORDS. Doesn't matter to us. When you go to build your APIs, we give you a couple of graphical user interfaces. We give you a command line interface, and then there's actually a REST API that you can use to define your REST APIs if you want. This technology is available if your database is in your data center, on your laptop, in a Docker container, in a Kubernetes widget, in our cloud, in someone else's cloud. It doesn't matter. Now, and in the autonomous world in Oracle Cloud, ORDS is pre-configured and good to go for your instances. But if you've got a bare metal VM inside of the Oracle Cloud, you could deploy ORDS to that and use that. And what I'm showing you today is the autonomous interface that I've got going for my always free instance, but I have another one set up on my virtual box here on my Windows machine for local work. So let's look at a boring example of a REST API. So I've got some entity, some collection that I've defined or I've modeled as as employees / and employee / represents all of the employees in my company. So if I were to do a get on employees, I would get back a JSON document that's paged of all the employees in my table or view, or wherever the results of the SQL tied to this thing is. In this case, it's literally select star from employees. And what ORDS is doing is it's taking each column of that result set or each row, and it's mapping it. It's rewriting it as a JSON document. And it's doing a little bit more than that. Since this has a primary key, we can see that. And so each record also has a link included. So if you wanted to go drill down on an individual item in this collection, in this case, an individual employee, that link is there that Patrick's app could take advantage of. And at the bottom of the JSON document, there are more links. So one thing we're telling Patrick's app is, hey, by the way, there are more things out there if you want. And if you want to go get the next page, follow this link. By default, we page these in groups of 25. That's configurable. You can page them any way you want. Now, when I made this request, I didn't say just, give me all the employees. I used a parameter mapping on the URL. I said, hey, additionally, I just want to see employees whose department ID is 50. And Ord sees that and goes, oh, Jeff wants me to add a where clause to the SQL that's defined to this resource. And so instead of running select star from, it's saying select star from where department ID equals 50. And so I'm just getting those employees. So I'm picking on Patrick just because he's a good sport.
Just because you can.
Just because I can, literally, yeah. So I mentioned this AWR. Well, actually, I should probably come back a little bit. So this is our web interface for managing your REST APIs. So this is delivered by Ord. So you install Ords, and out of Ords comes what we used to call SQL Developer Web. It's been rebranded to Database Actions. I don't like that. I like SQL Developer Web, but either way you say it, you're going to be right. There's a couple of different features that you get out of SQL Developer Web. Like there's a SQL worksheet that works just like the SQL worksheet on your desktop. When Jim's going to talk about the SOTA and the JSON stuff, we have a JSON interface to go deal with your JSON documents. And I think I talked about that in last week's session. So go look at the recording for that if you want to go see how that works. We're talking about the REST things today. And so we have a couple of different ways of implementing your APIs. We have this auto feature where you point to a table or a stored procedure and you say, hey, Ords, I want you to build the APIs for me to exercise those things, or you can create your own. And we organize those in things called modules. You can kind of think of them as a package. But one of my modules I've created is AWR. And I have created a template, AWR/. So when I call anything into Ords, the mapping pattern starts with this. This tells Ords what module I'm going to be calling. And then inside the modules, I have these things, these templates. And these templates represent the things that I'm trying to describe in a RESTful web service or a RESTful architecture. So one of the things that makes something RESTful is you have an item or a thing, basically a noun, and you're performing verbs against those things. So in AWR, we have something called snapshots. So I've created this template called snapshots, and now I have /ords/admin. So admin is the database user that the REST API is defined in. AWR is the module pattern or template, and then snapshots, that's this thing inside the module that I'm going to be using. Now I've got two verbs defined. So these are my HTTP methods, get and post. And let's look at the post one first. So when I said Ords gives you this way to take HTTP and turn that into SQL or PL/SQL, this is literally what that looks like. So I've got a PL/SQL block. This does the majority of the work right here. If I wanted to be lazy, this could just be a 3-line a 3-line call, a begin, or it could be even one, it could be exec this, right? And the response would be okay, or it worked, or whatever comes back from calling create snapshot. But I want to be a friendly API developer, and I want when Patrick uses my API to have a good experience. So in the definition of my REST call, I'm doing more work than just creating the snapshot. By the way, I could do even more work here. I'm assuming that this always works. I may want to have some exception handlers in here. Like for example, if create snapshot fails for some reason, I need to be able to account for that and provide a meaningful error message back to the API consumer. But for the brevity of showing this, I'm skipping that part and I'm just assuming it works. So I have this bind variable called status. So defining a parameter down here, having a status bind variable, I'm able to refer to that here. So it's basically the same as having a declare status as a number. But as a parameter, it's telling ORDS, hey, there's an attribute to either the HTTP request or the HTTP response. And so this status code is being mapped to this bind variable, which is being mapped to the HTTP response header. So when I call this, when it works, the HTTP response code is going to be 201. So I'm telling Patrick, hey, I created something for you. And I'm not stopping there either. I've also created a bind variable called snapshot, and I'm naming it snapshot on the response back out. And what that's saying is in the JSON document that's returned, the attribute value pair is going to be called snapshot, and I'm going to be assigning it whatever value I assign to this snapshot bind variable. So I'm running a select from all of my snapshots, and I'm saying, just give me the first. I'm assuming this isn't perfect, by the way, but there's probably a better way of doing this. But I'm assuming no one's created a snapshot in between me creating the snapshot and writing the select statement. And I'm including some more information into this. So let me show you what it looks like when I call this. So this is a REST client. It's a GUI. It's basically a more, well, for me, it's an easier thing to use than curl. Curl is the ubiquitous interface. It's a command line interface for making HTTP calls. But what I want to do is just, point and click and show and reuse stuff. So I've created an HTTP request of type post, and I'm calling it to that ords admin AWR snapshots. And I'm going to do a send. So this is going to my autonomous database in the cloud that's based in Ashburn, Virginia, which is like 300 or 400 miles away. It gets routed into my Oracle database. It does the PL SQL work, and back comes the response. You can see there's the post request. It's a thin, it is protected with authentication required and authorization required. And then the response comes back, hey, 201. And this thing that comes back is called snapshot. And what I'm returning is the snapshot ID, the instance number, and the database ID. So just to show you how this works, I could call this should be able to change this. Why is it not letting me change it? like my keyboard's not wired up. Anyway, if I change that to Patrick right here, the response would come back as Patrick here. So that's a post, but I also had a get. Come on, cloud. Here we go. So here's my GET request. And it's kind of, well, it's not a select star from at all. But it's pretty easy to read. So I'm selecting a few columns out of DBA hist snapshots. I've hard-coded the instance number because I know on this database, it has to be this. There's probably a more elegant way of doing this too. But again, this is just your SQL. The only tricks here for ORDS is, remember, we're very link driven, right? So I'm not just giving Patrick his snapshot ID and the things of interest for that snapshot ID. I'm also giving him links that he can use to go run these AWR reports. And the way ORDS knows that these should be displayed as a link is the column alias starts with this $sign. So when ORDS sees a $sign in a column or an attribute in a select-based API, it knows to print this as a link. And this .. slash followed by AWR report, I'm basically telling the link to be generated what the base of the URL should be, so I can go exercise the other part of the API. So I've called this already here. I've called AWR snapshots, and I again used that query parameter syntax. I'm saying I want specifically snapshot ID 8201. So here is what's coming back from that. Here are those links. So if I were to call one of these, it would actually go run the AWR report, and it would feed the AWR report the parameters it needs, which is the database ID, the instance ID, and then the start and stop time of the snapshots. And these links that are being generated are completely arbitrary. I'm basically just taking the current snapshot and taking the previous 5 before that. These values could be anything you want. Let's build another one from scratch, or let's go look at another REST API. So I was working on one for a blog post this morning. I'm a big fan of the interval data type. I think it's underutilized. So when I'm starting out, I want to create something new. I need to decide if that API fits into an existing module, or do I need to create a new one? If I want to create a new module, I just give it a name, and the name can literally be anything. And then the base path that represents that module. And then if I want to be nice, I can comment it. I don't know how you say blah, blah, blah in Dutch, but. So I've created this module. Now there's nothing in it. Now I need to create a template. So we could call it template, let's call it employees. So these would be Patrick's employees. Company. So this is the template. So this is the thing in the REST API that we're modeling. So what verbs do we want to do against it? Well, the easiest one is get. Here's that page size. Let's make it 10 for giggles. Patrick always cares about how much money people make. So we're going to order this result set by salary. That's hard coded into the REST definition. Employees, groups of 10, by how much money? Just in case. So we'll say create. Now I can test this here if I want, just to make sure that my query is going to work. And it doesn't. What did I do wrong? Do I not have an employee? I don't know if I have an employees table. So there's my SQL worksheet. I can actually see what's in my database. Yeah, I don't have an employees table, so it's kind of hard to query employees when you don't have employees. So we'll just go and do customers instead. So we'll come back to my employees module. Oops. We'll call this customers, people that bought Patrick's stuff. Obviously, this one doesn't make sense anymore. So we'll just start here. I haven't published this yet. I'm just going to see. Why is my data not coming back? Oh, it's an empty record. So into customers values. Jeff. Mr. Street. A. S. O. Say. And null. And my parser is telling me I missed a string enclosure. Okay, so now I have my row. And now if I run this, there's my record. So I'm going to save this. And if I go back to my REST client, Patrick's customers. There's that customer. Are there more records? Nope. We've exhausted the result set. Do I have a primary key on this table? Nope. So there's no link back to that specific record. But here's what I've got in that request. Also, I've not secured it. There's no security attached to this. So just because I'm nice. If everyone hit this right now, you'd go get that same record. As soon as I add a privilege to back this REST call, you're not going to be able to hit it anymore. Let's see if I can be faster than you. Now, if I go make this call again, 401 unauthorized. So I'm not authenticated. I can't hit the API. That's good. I don't want, in general, probably unauthenticated or unprotected resources. Now, if you have an open API and you're sharing data with anyone that wants it and you're not requiring any sort of authentication, then you're totally cool to leave these things open. So I've demonstrated so far, we've got SQL-based ones, we've got PL SQL-based ones. You don't have to write any code if you don't want to. So we have this auto feature. So you've already got a table, maybe you just want a CRUD API on that table. So you want an API where you can post a record to the table, you can replace a record with a put, you can get one record, you can get all of the records, or maybe you even want to batch load records. That's what we give you if you REST enable a table. Same thing on a view. For PL SQL, it's not really a CRUD API, it's more about remote procedure execution via HTTP. Running a program doesn't really fall into the RESTful architecture model. But ORDs, our main goal is to make the database accessible via HTTP. So we give you this auto feature for PL SQL. We just don't call it auto PL SQL. We don't call it auto REST PL SQL. We just call it auto PL SQL. So the way ORDs works, when we get that request, we start mapping the things in the URL to a database, because there can be more than one. So there's going to be a mapping pattern for the database. There's going to be a mapping pattern for that module. There's going to be a mapping pattern for the schema the module belongs to, and there's going to be a mapping pattern for the template. Once we know what everything is, then we can actually go look up the code behind the template. In this case, it could be a simple select. We're going to do the work, and then we're going to send the results back down to the client after we've paged them and assigned the appropriate status codes and written them out as JSON. So as a database developer or a database user, if you're being asked to build REST APIs, really the only thing you have to worry about is what's the SQL and PL SQL going to be? What do we want the incoming payloads to look like? So if we're calling PL SQL, how are you going to pass arguments to your program? If you're inserting records to a table, how are we mapping things to columns? And then what do you want the responses to look like? Do you want JSON records to come back? Do you want just single messages? And what should the status codes be? So you get just to worry about the SQL and PL SQL basically, and we handle all the other stuff. So here's just another look at unwinding these things. So ORDs in the URL, that represents the Java servlet or the WAR file. When you deploy ORDs to Tomcat or run as a standalone, if you rename that WAR file to patrick.war, then you would call your IP address, the port /patrick / everything else. If you have just a single database configured, then the next thing that comes is the schema that the API is defined in. We do recommend that you alias the schema. So what do I mean by alias the schema? When you configure ORDs, nothing is active in your database yet. So installing ORDs on a database doesn't open up your entire database to HTTP. That would be a nightmare, right? What you have to do first is tell ORDs that it's allowed to work with a specific schema. And you do that by enabling the user for REST. So I have this user in the database called CSV. I'm going to enable it, but I'm going to alias it as Qualogy. Where did I go? Yep. So now anything that I reference in this schema in terms of APIs, it's not listed as CSV in the URL, it's listed as Qualogy. And the important reason to alias things is so you're not exposing things in your database to your API consumers. The people using your APIs are probably different people than people actually logging into your database to do stuff. Then the module name, and then that template. And then these are the verbs that we support for words: get, put, post, and delete. There's an API, PL SQL API for words, so I can use that to enable schemas if I want. These endpoints, these REST services, they're organized per schema and they're executed as that schema. So if I enable this CSV user and I start publishing REST APIs inside of it, anytime I exercise the APIs in the database, they get executed as that user. So that means if Patrick the DBA has protected the database against bad Jeff user by only giving me a resource consumer group of, say, 5% CPU privs, I could create horrible APIs with like Cartesian join selects tied to them. But since those get run as my user in the database is never going to give me more than 5% CPU or whatever X% memory. So I'm not going to blow up the system just by publishing bad CSV or bad REST calls. And also Patrick has only granted my user read privileges on like 3 tables and only execute privileges on 2 procedures. So I'm not going to be able to define any REST APIs that do anything more than run selects on those tables of views or execute those procedures he's given me access to. So it's very nice in terms of like defining exactly what the APIs can and can't do. You're protected by the same security you have defined in the database. So installing words at install time, you're asked, hey, do you want to enable SQL Developer Web? If you say yes, then you can actually call these screens immediately outside of, call these screens immediately from words in your browser, and you can use words to manage words and the database. You can also use SQL Developer on your desktop. If you've got Apex, you can use that. But these REST screens I've been showing you have been available since last year. And from here, you can right click on tables and say enable, or you can go and build those modules from scratch like I showed you. If you want to use the command line, there's a Java command line for words itself, and there's also some words commands built into SQL CL. So the auto versus the RESTful web services or the modules. In auto, you don't write any code, but you also don't have any control. If you enable a table, you get exactly what we want you to have. So that's all columns. That's insert, update, delete, select, whatever. You don't get to say, I just want select on these 3 columns, and that's it. If you want to control, exactly what comes out of that, then you start building your own services. If you don't want select star from, if you want select this and that, then you're writing your own services. But if you have a table and you do just want to make it accessible via CRUD API, then you right click on that table and you say enable, and then you get batch load, you get selects for all the records, for individual records, and you get insert, update, and delete on those records. If you want to be able to say, hey, I want the response code to be this, if I want the JSON payloads to be that, and I want the responses to look like this, then you're writing your own services. Most customers will start with the auto just to get kind of like a hello world environment going. And then when they're comfortable with it, they'll transition over into writing their own services. However, I've talked to customers that have simply enabled their existing PL SQL, gave those APIs to their app developers, and their entire mobile app was built based on REST enabled or ORDS enabled stored procedures. So I'm not going to tell you which one's good or bad. So when you REST enable a table, I've said this like a bunch of times, we give you all of these different interfaces to it. This is what REST enabling a table looks like. Here's the PL SQL call. You can also alias that. Again, you probably don't want to advertise to your API consumers what the things in the database are called. You're just giving them an attack vector. But with the table enabled, then I can start just doing stuff to that table. So for example, give me all of my beers, or in this case, give me all of my beers that I've given a rating score of 5. And out comes back this data. I didn't have to write any code for this. Here's the Swagger doc, words it gives me for my REST enabled object. Here's another query. Here's a put. So no code necessary to make this available. If I REST enabled the object, I can simply do a put on the object, an item in that object that equates to a row. In the HTTP request body, I have a JSON document of the values that I'm going to use in the update. So I'm saying update this thing, and it's auto demo ID 12345678890, and I'm saying update set times equal to this, dates equal to that, numbers equal to this, and chars equal to that. And then the response that comes back is, okay, I did it. And oh, by the way, here's the location link to that thing that you just updated if you want to go look at it now.
Jeff,
yep.
There's one question. Does it mean that auto-REST is kind of prone to SQL injection since one does not have control over it?
No, I wouldn't say so. So you don't have control over the auto, but we do. And we're very, very security conscious. ORDS is subjected to additional scrutiny just from our own security teams because of how powerful it is and the nature of what it is. So no, all of our code that we use to generate these APIs are sanitized and built specifically for preventing SQL injection. You are very wise to be wary of things that can invite SQL injection, because even though we've been talking about SQL injection as an attack vector for databases for like what, 10, 15, 20 years, it's still one of the most common ways someone can take over your system. So you need to think about that kind of stuff when you're building your own APIs. But no, we put things into the product specifically to avoid that. Great question. Here's an example of REST enabling a stored procedure. So I have this stored procedure called give raises. It's actually a function, I think. And when I call it, I pass in a % that I want to use to be applied to increasing the salary of all my employees. And what's returned is a sum of the new total payroll as an integer and also a ref cursor of all the employees and their salaries. So when I REST enable this and I call it, here's the response that comes back from ORDS, like a 200, and then here's the JSON document. So ORDS is taking those two out parameters, or those, I guess this is a procedure, not a function, but here's the two out parameters from the procedure, a simple integer out and also a ref cursor out. And it's sending that back down to my client. Let's talk about security real quick because people care about security. If you need APIs for the database itself, we also give you an APIs for managing the database, including things like running data pump, running data dictionary reports, all kinds of good stuff. So when I gave you the link to go touch my stuff, if you were fast, you were able to pull it back. But if you were slow, you probably got that 401. the security model for ORDs you're protecting either a pattern or a module with privileges. These are not database privileges. These are like privileges that are tied to authenticated requests. So the name of the ORDS privilege is this. I've assigned that privilege to a couple of roles. Again, these aren't database roles. These are roles assigned to authenticated users that are making requests. And I'm using this privilege to tie down these mapping patterns. So anything that starts with this or this, if you don't have any of these roles, you're not going to be able to exercise, you're not going to be able to access. So if I create an API and I don't associate a privilege or a role to that API, then anyone's going to be able to access it. So how do you assign privileges or roles to authenticated users? If you're running words inside a Tomcat or a WebLogic, then you're probably going to have authentication handled there. So you'll have WebLogic and Tomcat tied to your existing user LDAP, single sign-on, whatever interface there. And then you tell those things when they pass their requests on into the ORDS servlet to attach the authenticated user and their roles that they have assigned to them. And ORDS sees those roles and it maps those roles to these roles defined here. So when you're calling /HR/module1/imps/123, it goes /HR/imps requires this privilege, and this privilege belongs to these roles, and this person's authenticated as Jeff, and Jeff has this role, so they come in. Oh, Jeff doesn't have this role. Okay, they get the 401, not allowed. Go give me a proper authentication scheme. ORDS also provides the full OAuth 2 workflow. So if you don't have an existing user store or single sign-on repo to kind of call on, ORDS allows you to create OAuth 2 clients, and you can assign those clients the roles you want them to have, and then you can walk the OAuth 2 workflows to access your REST APIs. So the first thing you would do is request a bearer token. So you would literally do this. And the response that comes back is going to be, oh, here's your token. And then when you go to exercise the API, you include this token on the request. And that's good for like 30 minutes until it expires. Or 90 minutes or 60 minutes or whatever you've assigned it to. And then when it expires, you'll get a notice that asks you to go get a new bearer token.
Jeff, there's another question.
I'm looking at it now, yeah. Does ORDS populate its data in relational model rows and columns? Yeah, so the responses are JSON, but when you're putting stuff into the database, it goes into the database. And if in the database you have a table, yeah, it goes in as tables, or sorry, it goes in as rows and columns. If you're working with the JSON document store, they'll go in as documents. They'll go in as blobs or clobs or JSON records in those tables. And if you want to see how to create an API, you start by creating a model or a module, and then you create a template, and then you create the verbs, and then you put stuff to the verbs. So I've got a module called sales history. I've got a template called total sales by zip code. I've got a get handler attached to that runs this. I don't know what my zip codes are. Yep, so what is total sales? But there, the response is going to get back as a JSON document to my API. It's whatever the SQL is fed to it. Here I was a function call. Here's a bind parameter. So in the URL mapping pattern, I've got something called mf breakdowns /:in. So if I do a get on mf breakdowns 5, that 5 words passes it to the function call because I'm referencing it as :in the SQL, and it knows to get that value off the in the URI of the HTTP request. So it knows to feed that to that. So it's going to call this function with the value of 5. I've got tons of examples here. Probably the most popular example I have is how do I upload files and download them? And all it is a table with a blob. And I've built APIs that work with those blobs, which allow you to upload the blobs and download the blobs and even change the blobs. And I got all the code here. And it's pretty simple. Really, the tricky things are, dealing with the links, figuring out how the bind parameters work. But this is all documented. And if you ever get stuck, try Google. And if you don't even want to do that, just come tweet me and I'll be happy to help you through it. Or go bother Patrick. He's seen this a couple times. He's an expert now.
Yeah, I'll relay the question.
There you go. I've got to run. Thanks so much for the time. Wow, you give me 2 hours in 2 weeks. I appreciate that. Hope everyone is doing okay physically over there in your side of the world and that we're able to meet in real life at some point. Enjoy the rest of your week, folks.
Okay, thanks, Jeff. Bye. Run. Okay, so Jeff had to really run. His next thing is starting just about now, I think. Like I said, we hope you join us again in 2 weeks' time for Jim Zabrinsky's talk on JSON, a splash of soda, and the SQL chaser. And for the rest, I wish you a nice evening and hope to see you again in 2 weeks.